Hello, it's been a while. This is my English speaking practice, and I'm talking about how I solve the coding problem. And today's problem is peaking iterator. Oh, interesting. Design an iterator that supports the peak operation on an existing iterator in addition to the has next and the next operations. Implement the peaking iterator class. Okay. Peaking iterator initializes the object with a given integer iterator, and next function returns the next element in the array and moves the pointer to the next element, and has next function returns true if there are still elements in the array, and peak function returns the next element in the array without moving the pointer. Each language may have a different implementation of the constructor and iterator, but they all support the next and has next function. Okay. So below is the interface for iterator, which is already defined for you. Iterator is like this. Peaking iterator, right? And your peaking iterator object will be instantiated and called as such, like this. Okay. Okay. They already defined iterator class, simple iterator class, and has next. Okay, has next and next function is already already defined. So how about use it? So all we have to do is just to implement the peak function, return the next element in the iteration without advancing the iterator. So we cannot use this because the next function returns the next element, but it moves the pointer. It moves the pointer forward, right? So but I don't okay. So this is iterator class, and it takes numbers internally, so we can use this, I think. So we initialize the pointer like this, and next function. So I think the first call of the next function would be the first element, head of the internal list of integers. So the first pointer should be -1, right? And when we call next function, oh, okay, this is 0 is okay, because this function returns the next element in the iteration. Okay, so next value would be iterator. Oh wait, but we cannot find out we cannot access the list of internal list of integer. So how can I iterator nums. So if the name of the internal list is nums, we can access like this, and return like this. And here we have to increment the pointer. And all the call to next and peak are valid. Okay. So we don't need to think about the case where the pointer is the out of index of the list. So yeah, this is the implementation that comes to my mind first, but I'm not sure this works, so let me run it. Okay, iterator object has no attribute nums. Okay. So how can I... Okay, we cannot use the pointer. Oh wait. So, since we cannot access the internal list, all we can do is using these two functions. So, when we call when peak function is called, we have only one option, and that is calling next function, right? Yeah, but so when okay, let me initialize the buffer as a temporal value, and when the peak is called, if okay, if buffer is 0, it's not valid, so it means there is no valid value in the buffer, so we have to find out the next element with calling the next function, right? And at the same time we have to store it to the buffer, because we have to prepare for the call of peak function in the future, so we keep the next value in buffer, right? And return the value, right? And otherwise the buffer is not 0, it means there is a valid value in the buffer, and valid value means the next element, right? So yeah, we just return the value in the buffer, right? And the complicate is next function, because if buffer is 0, if buffer is 0, it means there is no next element stored in the buffer, right? So okay, it's simple. Return iterator next. Yeah, it's same as the normal case. And otherwise, next bar should be like this, and return next value. At the same time, we have to restore the buffer to the initial state, right? Because the pointer should be moved, so it means the value in the buffer would be clear, and yeah. Okay, and this is similar, because the buffer is 0, it means same as normal iterator. There is no value in the buffer, right? And otherwise, it's always true, because the next value exists in the buffer, so has next. Let me see the results. The name buffer is not defined. What is it? Oh gosh. Self buffer. Self buffer. Right. Let me see the results. Great. Submit it. Okay. Great. And there are follow-up questions. How would you expand your design to be generic and work with all types, not just integer? So yeah, make it more difficult, making it more difficult. So this is the value, so we can copy the value itself if the value is integer, right? But yeah, if I extend this design for all types, and the buffer needed to store the pointer that point to the value, right? So self next value, yeah. Self next should be return the pointer. Return the pointer. The value is 0. So the 0 becomes into null pointer or something like that. And we have to differentiate the valid pointer or not, right? But basically the same. So the buffer stores the pointer, and this function returns pointer. The buffer would be pointer. Yeah. Okay, so it's okay. Okay. Okay, I'm gonna solve one more question. Find the duplicate number given an array of integer nums containing n plus 1 integers where each integer is in the range 1 to n inclusive. There is only one repeated number in nums. Return this repeated number. You must solve the algorithm without modifying the array nums and use only constant extra space. Okay. Repeated number, right? One, two, and inclusive. One, two, three. All the integers in nums appear only once except for precisely one integer which appears 2 or more times. 2 or more times. 2 or more times. Okay. and I can use only constant extra space. One, three, four, two, two. 1, 3, 4, 2, 3, 3, 6. One to n plus 1 integers. I see. So 5 integers, so the range would be 1 to 4 inclusive. Okay. Okay. Let me think. So basically, zero we have 3 patterns, right? For 1, appear once, 2 appear twice, 3 appear once, 4 appear once, right? So basically the number would be appears 0 times or once. So if we iterate through and exclusive OR, apply the exclusive OR, we can remove the numbers that appears once and 0 times, right? But the problem here is the number that appears even number times would be also disappeared. Because because of the property of the exclusive OR. But if it appears odd numbers like this, it's not good. It also disappeared because it appears even numbers in total. Okay. But this case, it's not good. No. This is what I was thinking about. If there are 2 times 1, 2, 3, 4, so we can get the remaining 2, right? So two or more. This would be classified into odd or even, right? If it's even, we can identify the duplicated number. Is it correct? So there are 4 2s and 1 1, right? 1 is removed, 2 removed, 1 2 remains, and 3 and 4 also remains. That's not good. That's not good. only once. This is another example. N plus 1 integers and N 1. So normal case. This is the normal case. 1 to n and additional element that is in range 1 to n. How to find? If there is a number that doesn't appear at all, it should be replaced to the duplicated one, right? Because there is only except for precisely one integer which appears two or more times. So if it appears, it should be only once. Yeah, so this is the case. Duplicate it twice, 3 times, 4 times, 5 times. And mm? 10. The total would be 10, right? Total would be 10. So the total, if the total is 14, the difference is 4, so we can find out the answer is 4 in this case, but there are a lot of other cases, but so 1 to n plus x, right? 1 sum 1 to n plus x. Base case. So x equal total minus sum 1 to n. if x is range from 1 to n, maybe return x because x is the answer, but I'm not sure this is always true. I need to prove this. How about this? 6, 7, 8. So the difference is -2. -2, -2, -2. What happened? -2? So 1, 2, 3, 4. So basically the difference would be a positive value. Yeah, because we assume there are values appears once, so we can achieve the total value of the 1 to n basically, and we assume there is additional 1, right? But if the total is below it, it's not the base case. It means there are 3 or more duplicates. The duplicate number appears 3 or more times, like this. Hmm. So this case we can find 1, 2, 3, 4. So the output is 4, right? XOR. The output is 4, right? Output is 4. Output is 4. In this case, 1, 2, 4. So we cannot get any information from this 1, 3, 1, 2, 4 remains. 1, 2, 4 remains. Yeah. So this is a simple case. Once we can find out the answer appears twice, we can find the answer, right? Oh, 3 times, 4 times, 3 times, 4 times. 3 times, 4 times. Oh wait, we cannot create a new integer list because constant extra space. So this is not correct. This is not correct, I think. 1, 2. So maybe the information we can use is total of nums. Let me code it total. And x. exclusive or mm. Mm? This is constant space. This is the constant space. We can get to yeah. Mm. There is duplicates. Must be duplicates. Means 6 1 2 3 1 3 4 1 3 4 4 3 1 6. Okay. If there is 2, one, two, three, 4, 4, 4, 4. Should be 4. Should be 4. Ha 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 ha. Right. Should be 4. Should be 4. Should be 4. Okay. But 6. Okay. So we can find 2, right? How about let me try 0 x y and yeah, this is correct. This is correct. This is what this what 3 3 3 3 3 3 3 3 3. Okay. Case 1 and case 2 is the normal cases, so yeah, this solution works. This solution works. But yeah, for example, this case 1 2 3 4 1 2 3 4, and we compare this one. One, two, three, one, one. 1 2 3 1 1. 1 2 3 1 1. 1 2 3 1 1. Let's see. One, two, three, one, one. Second part would be always 4. Huh. 1 2 3 1 1 1 2 3 1 1. 1 2 3 1 1 1 2 3 1 1 0. Exactly. Duplicate. How to find duplicate? Should be 4. Why should be 4? 1 2 3 4. Because 4 is the most biggest digits. Right. 1 2 3 4 5 4 5 6 7 4 5 6 7. 4 5 6 7. So this case 0 0 0 0. There is no false. No fall or two falls, right? No fall or two falls. Two three 2 3 2 3. 2 3. 2 3s. There are 2 3, a pair of 2 and 3, or 2 2s and 0 3, or 2 3s and 0 2s. 0 means, 0 means 0 0 0 0 0 0 0 0, but the expected answer is 4, so let me think about this case. There is no false, so no false, so the expected answer would be 2, and so the answer is 2. Not correct. Answer is 1. Answer is 1. We cannot detect the answer because 3 1s and 1 3. So this bit got true 4 times, so we cannot detect. What you gonna do? It's time over. It's time over. Let me see. Linked list cycle. Wow. This is smart solution. Let me see the Python 3. Interview approach, 7 approaches, brute force. Okay. Sort the array. It's not good. It's not good. Mark visited element negative. Maybe this is the simplest. So let me see. Get the index and get the value. What? If it's already visited, return the index. Okay, I understand. I the way I thought is biased. Because yeah, that is caused by this message. Yeah, using only constant extra space makes me think, oh, I should solve this problem with like this, like bit operation, bit manipulation. Yeah, because I thought I I have I have solved these kinds of problems with these solutions. Yeah, so I was biased to this problem. Yeah, but we cannot solve this problem in that way. Yeah, the point is, the key point is, there are n plus 1 integers and the value is in the range 1 to n, so the value can be used as index of the list. So the simplest solution would be this one, I think. Yeah, the index can be used and the value is also used as index, right? And it marked it as visited by apply negative value, make it negative value, right? Yeah, it's so smart. Tortoise method. What is this? Slow and fast. This is finding cycles. Slow pointer and fast pointer. Yeah, if it's same, we can find the cycle. So the first find the cycle, and the first pointer is first pointer is set to the head, right? And slow is a position. Slow is the position where the first pointer comes from the back. I don't know. Anyway, in range randoms and index would be absolute nums I and the value is edx, if value is negative, return which is what. We want to find the duplicate value, so yeah, duplicate value is the index, and otherwise great. Okay. I'm done. Let's call it a day. Thank you for watching.